This video goes over examples of operations with polynomials. So the first thing that I'm asking you to do is to simplify the following. So in this first example here, I'm going to get rid of the brackets to start. And then I'm going to look for my like terms. So I'm going to start off with my x squared. I've got one of those. And I've got 2x, 5x, and then I've got my numbers at the end. All that's left for me to do is to collect those terms and then write them in order as x squared plus 7x minus 7. My next one here is more of the same, except I've got a negative sign here that is going to apply to each of those terms in the second bracket. So I've got 3x squared plus 5x minus 4 minus 2x squared plus 7x minus 3. Repeating the same process I did, I'm going to underline my x squared terms and my x terms and finally my constant terms, and then my final step is to put them all together. So x squared plus 12x minus 7. My third example in part A is more of a word problem. Now I'm asking you to subtract the sum of these two polynomials from a third polynomial here. So what I need to do is to translate that into an equation. So I know I'm subtracting from this polynomial, so this is where I'm going to start. And I'm going to take away the sum of the first two polynomials that I've labeled there, plus 3x squared plus 2x minus 9. So just like 1 and 2, I'm going to get rid of the brackets. In my square brackets over here. And then I'm going to collect my like terms in the square brackets and then continue simplifying. So I've got my x squareds, my x's, and my constants. So now my question is 7x squared plus 6x minus 7 minus 4x squared plus 7x minus 16. Just like in example 2, my negative sign applies to all three terms in that bracket. So now I've got 7x squared plus 6x minus 7 minus 4x squared minus 7x plus 16. Again, underlining my x squareds, underlining my x's, circling my constants, and combining them all together, I get 3x squared minus x plus 9. Let's do some more examples with multiplying polynomials. If you have two binomials multiplied together, you're going to apply FOIL, first, outer, inner, last. There are lots of ways to remember this, but you need to make sure everything in the second bracket gets multiplied by everything in the first bracket. So here I've got x squared minus 5x plus 2x minus 10. Collecting those middle terms together gives me a final answer of x squared minus 3x minus 10. So a little bit trickier. Now I'm starting off with 3x minus 4. This is actually the same as the first question because I have my bracket multiplied by itself. Again, I can apply FOIL, first, outer, inner, last. 9x squared minus 12x minus 12x plus 16, which I can simplify by collecting those two middle terms as 9x squared minus 24x plus 16. Just dividing that up. Okay. Our third one is another example of FOIL, but this time it has a constant in front of it. You have two options. You can either multiply the second two brackets first, or you can distribute the 3 into the first bracket and then multiply it from there. I'm going to choose that option. So my 3 is going to distribute into the first bracket only. And now I'm left with another FOIL situation. So 6x squared plus 36x plus 9x plus 54, which I can simplify to 6x squared plus 45x plus 54. If you'd multiplied the second two brackets together first and then multiplied 3, you would also get the same answer. Okay. Another example here. Now I've got my constant and I have my squared bracket. That bracket means 2x minus 3 multiplied by 2x minus 3. I'm going to distribute my negative 3 into the first bracket. And now I have the same situation I did in the previous 3 questions, an example of FOIL. So minus 12x plus 18x squared plus 18x, and then minus 27, which I can simplify a little bit further by collecting like terms as minus 12x squared plus 36x minus 27. Our final 2 examples here. Example 5, another example of a constant times 2 brackets. So the first thing I'm going to do is distribute my constant into the first bracket only. And now I'm going to use FOIL to multiply the resulting brackets together. So 6x squared minus 4x plus 6x minus 4. Collecting my like terms in the middle, I now have 6x squared plus 2x minus 4 as my final answer. Our last one is the most complicated. It has the most pieces, but let's go ahead and see what we can do. So 4x minus 3, I'm going to leave that alone for right now, and I'm going to work on simplifying what's inside the square bracket. First thing that I need to do is recognize that I have a squared, an exponent. That is the same as x minus 3 times x minus 3. That is the first thing that I'm going to do, is I'm going to leave everything else alone, and I'm going to expand that bracket there. So x squared minus 6x plus 9. And now I can continue by distributing the binomial into my trinomial. It's important to make sure everything in that binomial gets multiplied by everything in the trinomial. So I've got 2x cubed minus 12x squared plus 18x plus 7x squared minus 42x plus 63. Holy smokes. So let's consolidate that a little bit before we deal with the 5 and our last binomial. So I've got an x cubed. I have 2x squared terms. I have 2x terms. And then finally, I've got a constant at the end. So I've got 5 minus 2x cubed minus 5x squared minus 24x plus 63. Then I could add the 5 in there. So now I only have a polynomial times a binomial. So I'm going to end up with a lot of terms. Minus 2x cubed plus 5x squared plus 24x minus 58. My final step is to distribute that binomial, making sure that everything from the first bracket gets multiplied by everything in the second bracket no one wants to be left out. After doing that, we've got 8 minus 8x to the 4 plus 20x cubed plus 96x squared minus 232x plus 6x cubed minus 15x squared minus 72x plus 174. Finally, consolidating all our like terms, minus x to the 4 plus 26x cubed plus 81x squared minus 304x plus 174. You should be comfortable expanding and simplifying those types of expressions.